Hello everyone, welcome to my channel. Today we are going to learn the basic C programming and the pre-processing part. How does the programming actually works and how the CPU understand our code. So let's start it. So we will go through the basic C programming. First of all, I will create a new uh, folder where you can see my first C program, which is basically a hello world type of program in which how the compiler will works. We'll discuss on that. So in VI editor I just try to somewhere something went wrong. I include an header file stdio.h, which is basic input output file. In that I created one function which is main entry point function through which our code goes. So in that I just write a statement printf in which I print how code executes and how CPU can understand our code. So this is a just an basic example so that you can go through all the steps of execution. So we are done with our program. I compile it. At the compile time we need to give the command, which is -save -temps. Now this is the command which is make and change in the execution process. Like we normally type gcc or project name .c file, which compiles the code, and we can directly check our output and on .exe file. So this command will show you all the execution files. So once I enter, here you can see nothing, but if you type ls, it will list out all the files which are generated by -save -temps. You can also check that how gcc help us on gcc -helps command. Sorry, my mistake, it's help. So in this you can see there is an -save -temps now. So do not delete intermediate files. So this is what we done. So it will not delete any intermediate file which comes in an execution process. So let us see one by one, and first of all we will check the pre-processing execution in C programming. Can we find images? It's better to understand as well. Yeah, okay, I got it. So first of all, our editor or ID which we are using, the VI editor. So the source code which we written in .c file, the steps are preprocessor, compile, link, edit, load and execute. So we generated all these files .o. The assembly file is not here. Okay, another one, sorry, it's not at all. Okay, I found the another one. Okay, here we have a source code. It is more relevant to the our code. Okay, so this is a source code .c file. Then we expand a macro which will get .i file. Then the assembly code that .s file and machine code .o, that is object file. So let us check one by one. So control ls. So the first file is our demo1.c. So the second one is comes in process, include header, expand macro, which we added a header in our file. So we'll check that first, demo1.i. So here we was, the actual line of code is 180 line. You see here, let me show you. The total line of code actually is 140 lines. So this is our code, and the pre-processing, at the time of pre-processing or the macro expansion, include header or expand macros, so it will load those 840 lines of code before compilation. So after compiling, the assembly code generate .asm, which is more relevant for an machine. It is more closer to the machine, so we'll check that one. So yeah, in this, as we know that in electronic programming we mostly use this type of coding, which we call an assembly level language, in that we have to deal with the registers and all those stuffs. So like we are moving some values from this to that, the variables whichever used. So this is our basic C program, and the GCC itself generate all those files. So this is .i file, and after that demo1.o. So we'll check that as well. Okay, so this is an object file, but we can't read it. The issue is we don't have that type of editor in which we can understand an object level file, so it will directly goes to an execution machine code, that is .o file. And we can execute our code by ./a.out. So this is an executable file which is already generated here. You can see it here. If I press enter, it will print the message which I have given. Okay, I need to show in correct way, sorry. I need to enter and /n at the end so you can understand it very well. So I did not insert. Okay, so this is the execution process of an program. It's like an behind the scene, so we can, which was done by GCC compiler, and we can check this out with the help of GCC demo1.c -save - temps. So here we go, the assembly code. So this is our assembly code, and the macro which we have to After executing this, we will generate all the .i, .o, .s files, and of course ./a.out, which will give the output of our project. Hope you like the video. Thank you.